Operations Manager Paul Garner reports go for launch. Launch Director Rocco Petrone now gives a go for 5 minutes, 20 seconds and counting. Coming up shortly, that swing arm up at the spacecraft level will come back to its fully retracted position. This should occur at the 5-minute mark in the count. In the meantime, the lunar module telemetry has been powered down. We took a good look at Eagle, and it looks good. The spacecraft test conductor for the lunar module reported that Eagle was go. The swing arm now coming back to its fully retracted position as our countdown continues. T-minus 4 minutes, 50 seconds and counting. Skip Chauvin informing the astronauts that the swing arm now coming back. The astronauts will have a few more reports coming up in the countdown. The last business report will be from Neil Armstrong at the 45-second mark in the count when he gives a status on the final alignment of the stabilization and control system. We're now passing the 4 minute 30 seconds mark in the countdown. Still go at this time. 4 minutes, 15 seconds. The test supervisor now has informed launch vehicle test conductor Norm Carlson you are go for launch. From this time down, Carlson handles the countdown as the launch vehicle begins to build up. We're now hitting the 4 minute mark. 4 minutes and counting. We are go for Apollo 11. We'll go on an automatic sequence starting at 3 minutes and 7 seconds. 3 minutes, 45 seconds and counting. And the final abort checks between several key members of the crew here in the control center and the astronauts. Launch Operations Manager Paul Garley wished the crew on the launch team's behalf good luck and Godspeed. 3 minutes, 25 seconds and counting. We're still go at this time. We'll be coming up in the automatic sequence. That takes 10 or 15 seconds from this time. All still go at this time. Neil Armstrong reported back when he received the good wishes. Thank you very much. We know it will be a good flight. Firing command coming in now. We are on the automatic sequence. We're approaching the 3 minute mark in the count. T-minus 3 minutes and counting. T-minus 3. We are go with all elements of the mission at this time. We're on an automatic sequence as the master computer supervises hundreds of events occurring over these last few minutes. T-minus 2 minutes, 45 seconds and counting. The members of the launch team here in the control center monitoring a number of what we call red line values. These are tolerances we don't want to go above and below in temperatures and pressures. They're standing by to call out any deviations from our plans. 2 minutes, 30 seconds and counting. We're still go on Apollo 11 at this time. The vehicle is starting to pressurize as far as the propellant tanks are concerned, and all is still go as we monitor our status for it. 2 minutes, 10 seconds and counting. The target for the Apollo 11 astronauts, the moon at liftoff, will be at a distance of 218,096 miles away. We've just passed the 2 minute mark in the countdown. T-minus 1 minute, 54 seconds and counting. Our status board indicates that the oxidizer tanks in the second and third stages now have pressurized. We continue to build up pressure in all three stages here at the last minute to prepare for liftoff. T-minus 1 minute, 35 seconds on the Apollo mission, the flight to land the first men on the moon. All indications coming in to the control center at this time indicate we are go. 1 minute, 25 seconds and counting. Our status board indicates the third stage completely pressurized. 80-second mark has now been passed. We'll go on full internal power at the 50-second mark in the countdown. Guidance system goes on internal at 17 seconds, leading up to the ignition sequence at 8.9 seconds. We're approaching the 60-second mark on the Apollo 11 mission. T-minus 60 seconds and counting. We passed T-minus 60. 55 seconds and counting. Neil Armstrong just reported back it's been a real smooth countdown. We passed the 50-second mark. Power transfer is complete. We're on internal power with the launch vehicle at this time. 40 seconds away from the Apollo 11 liftoff. All the second stage tanks now pressurized. 35 seconds and counting. We are still go with Apollo 11. 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9, Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
Here we got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on proper heading. Plus 30 seconds.
Roll is complete and the pitch is programming. 1 Bravo.
1 Bravo is a abort control mode. Altitude's 2 miles.
Apollo 11 Houston, you're good at 1 minute.
Downrange 1 mile, altitude 4 miles now. Velocity 2,195 feet per second.
Start bottle pressure red line is lit. I don't... Where? Yeah, it don't make a difference. No difference. Okay, let's punch them out. Everything is go, Ralph.
We're through the region of maximum dynamic pressure now.
Yeah, everything looks good here. We're at 1350 on the start bottle.
8 miles downrange, 12 miles high. Velocity 4,000 feet per second.
Stand by for mode 1 Charlie. Mark, mode 1 Charlie.
1 Charlie.
Cliff Charlesworth taking a staging status.
This is Houston, you are go for staging.
Inboard cutoff.
Inboard engines out.
I'm inboard cutoff.
Downrange 35 miles, 30 miles high. Standing by for the outboard engine cut down now.
Staging. And ignition.
F4B is go.
11 Houston, thrust is go. All engines, you're looking good.
Roger, you're loud and clear, Houston.
At 3 minutes, downrange 70 miles, 43 miles high, velocity 9,300 feet per second.
We got skirt step.
Roger, we confirm skirt step.
Tower's gone.
Roger, tower.
Neil Armstrong confirming both the engine skirt separation and the launch escape tower separation.
Houston, be advised the visual is go today.
This is Houston, Roger, out.
That's right.
Yeah, they finally gave me a window to look out.
You won't, he can't hear you.
11 Houston, your guidance is converged, you're looking good.
Downrange 140 miles, altitude 62 miles, velocity 10,300 feet per second.
11 Houston, you are go at 4 minutes.
Roger.
Welcome to Visions, a series of visits to almost everywhere. I'm your host and fellow traveler, Herb Malsman. That was July 16th, 1969. Neil Armstrong and company are on their way to the moon to take that first small step. We, on the other hand, are about to take a today look at the U.S. space program. Here we go. We're about to spend a couple of days at Kennedy Space Center at Cape Canaveral, Florida, right near Cocoa Beach. We're staying in Titusville, and my daughter and I, we're going to be spending a couple of days there looking over the complex. Let's take a moment now. We're in the press site at Kennedy Space Center, and a lady I've been speaking to over the last year and a half anyway, getting ready to come out here, Lisa Malone. We're going to meet briefly Lisa Malone because she's very busy, I guess, kind of getting ready to go, I guess, break for the day at this point. It's getting kind of late. We are going to speak for a moment with Lisa and say hello, and then get a little idea of what we're going to be doing over here for the next couple of days. Good morning, Lisa, and your good afternoon, I guess, at this point. Your title and your responsibilities, and you're also the first female voice of, is that right, here at NASA? Talk about that for a moment.
Okay, my name is Lisa Malone. I'm the Chief of Media Services here at the Kennedy Space Center, and what that means is all of the news media activities that go on at Kennedy Space Center around launches, landings, missions, all sorts of activities dealing with the space shuttle. Those all occur, and all those events are staged out of this office. have a staff of about 18. We have an area where news media can pick up news releases and press kits about things going on with NASA. They can pick up photographs and videotapes to use in the news coverage. And we also provide a live satellite feed of the space shuttle launches, and what that is about 6 hours of launch commentary. And I am one of 3 commentators, and we provide the details going on in the countdown, the final hours before the shuttle actually lifts off. So we are trying to describe the activities going on right in the firing room and out at the launch pad and with the astronauts as they're getting ready for their launch day. And a lot of what is heard over the loudspeakers is engineering jargon and acronyms, and our job is to translate all of that into simple, easy to understand language. And there's all sorts of things that go on in the course of the countdown. It's very exciting. It's dynamic. There's any component on the shuttle could possibly have something go wrong with it at the last minute, and our job is to explain what's going on and try to tell the listeners exactly where we are in the countdown and what the options are.
Yeah. Who was the first voice of
shuttle?
With Dave Shorty Powers? That name sounds familiar.
I believe he was the first person from a NASA Public Affairs employee to do a launch commentary, and that was way back in the 60s, and there's been several over the years.
I think that was John Kennedy's buddy. They were friends.
I don't know about that.
Yeah, they may be. So you're the first. Okay, so we're going to spend a couple of days over here, and you're my contact over here since I began calling. Thank you very much. We're about to move along. What are we going to be doing?
Well, you'll have the opportunity to go visit the crew quarters where the astronauts live and where they get ready for the launch, where they practice. There's a little dormitory area where they spend their nights. As you know, they are in quarantine when they come down here, and that's why we have them in a special area, sort of sequestered away from everyone. We wouldn't want them to go on to a long flight and become ill and sick and come down with a cold or anything that would hamper them in their mission. They've been studying usually a year to 2 years for any particular flight. A lot of training goes on, and the crew needs to be feeling their best when they're up in orbit.
And then I think we're going to be talking about Mars, and we're going to be talking a little bit about the space shuttle. I think hopefully we're going to get to the White Room and on the pad and check it out. Okay, before we close, say something in commentator.
This is shuttle launch control. The countdown clock is now at T-minus 3 hours and counting.
Continuing our look at Kennedy Space Center here in just I guess off Cocoa Beach, hard by Titusville, where we're staying for the night. But we're somewhere near Cocoa Beach right now. We're with George Diller, and we're going to get a little geographical background on where we are right now. We're in the press site, at Kennedy Space Center. We're going to take a look at the press site in a little bit. Well, first we're going to talk about Mars. Mars is coming up. I think we have a landing coming up, the 4th of July, Independence Day. There's a Mars probe going out. We're going to meet George Diller right now. And George, good morning, good afternoon, good evening. Talk about the Mars probe a little bit and a little of your background before we go into the nuts and bolts.
All right. Well, you were talking some about the geography of Kennedy Space Center and Cape Canaveral. Most people don't realize how big this place is. It's 34 miles long and 10 miles wide, and it's not very easy to walk from place to place around here. In most cases, you have to drive between launch complexes or launch facilities, and we're really sort of divided into 2 separate areas at what we geographically call the Cape. There is an Air Force part and there is a NASA part, and down the middle is the Banana River. NASA originally started out on what is the Air Force territory and is now called Cape Canaveral Air Station, and that's where we did the Mercury and Gemini programs and where we launched our very first satellite, Explorer 1. Those were done from some of the early pads over there, such as Complex 14 and Complex 5, and we still have launch pads over there for our unmanned flights that do our planetary launches, like for the Delta rocket, which is Complex 17, Complex 36, Atlas Centaur, that's done some of our Pioneer probes, and Complex 40 and 41, that's done our missions to Mars, and the Viking flights, and the Voyager to Jupiter and Saturn and Uranus and Neptune. In that context, we are embarking on a very ambitious plan of launching what are now definitely 9 missions to Mars and will probably be as many as 11. It's a whole different approach to exploring Mars than what we had in the past. The reason for that is twofold. First of all, you may recall that the Mars Observer spacecraft vanished about 3 years ago when it was launched on a Titan rocket from Complex 40. We don't know exactly what happened. We have some good theories as to what probably occurred. But the bottom line was that a very large spacecraft like that cost on the order of $1 billion, that while it would have been a real bonanza in terms of science, that it would have given us about Mars in a very short amount of time, that when spacecraft cost that much, if you have a catastrophic failure, then you've basically lost too much. You've got too many eggs in one basket in view of what it costs to replace it. So rather than build another Mars Observer, we decided to take a different approach and bite off little bits at a time, and came up with a plan that says, all right, over the next 10 years, we're going to launch a whole series of probes, each one with a very specific objective, and we'll build on each one of those missions and bite off a little bit as we go along and digest it, and then decide based on that series of flights what our next series should look like. And if you lose one somewhere along the way, you haven't lost so much. All of these craft are designed to be much smaller in character, in size, and cost much less money. And so what we have just done with our first 2 craft that we launched to Mars earlier this year, the Mars Global Surveyor and the Mars Pathfinder, they are very small compared to the Mars Observer spacecraft, or compared to one that we're going to launch in the fall called Cassini, which is going to Saturn. That is the last of the extremely large spacecraft that will bring back a major science return in a short period of time. The Mars Pathfinder, which is the spacecraft that is actually going to land on Mars and deploy a rover to go out and look around, that spacecraft can sit on a workbench. It's not any bigger than something that could sit on top of a very large desk. The actual rover itself is a very small thing that it looks almost like a toy. And in fact, I believe JPL, Jet Propulsion Laboratory, has licensed Mattel to make a small model of that for children that'll come out after the craft is on Mars. And that's the trend now, is to go to much smaller and smaller spacecraft because it costs less money, plus the technology that exists now allows us to miniaturize a lot of this. And just for example, some of the technology that's been developed through NASA and the private sector is being applied, but also a lot of what came out of the research and development during the Strategic Defense Initiative. Star Wars has allowed us to take a lot of the miniaturization techniques and optical processes to make very small spacecraft. So that's what our 9 flights over the next 10 years are going to do, is start out by looking around the surface and picking up where Viking left off and deciding based on that where we go. We're going to launch a probe next year that will actually have a little drill. It will drill down into the surface and bring up a sample and analyze that. There'll be another Martian rover that will have different objectives than the one that's going to land this coming 4th of July. But ultimately, we will decide whether or not, based on the data that we get from all of these small probes, whether it's worthwhile to undertake a much more ambitious project, which is what we call Mars Sample Return. And that's to actually dig up a sample of Mars or bring back a Martian rock on a probe that we've sent to the planet and then launched it back to Earth and recover that sample to do an analysis. It's all gotten very interesting because of the fact that this meteorite has caused all of this interest about whether or not there is or was life on Mars, which it's still inconclusive. And we have a class of scientists that says yes there is, and there's a class of scientists that says no there's not. And that was one of the very frustrating things about Viking when we launched that in 1976. The data that came back from those craft was conflicting. Some of it said that there was life or had been life or could be life, and other data said, no, that's not the case. We know that Mars started out at the same time in the same way as the Earth did, but for some reason evolved very differently, and all of the oceans disappeared, and all of the early chemistry for life disappeared, and we don't understand why. So what we're trying to do now is to find out, why the evolutionary process on Mars was short-circuited, and how far did it get. And we believe that based on a whole series of probes over the next 10 years, that in the long run, we'll be able to answer whether it is worthwhile to send humans to Mars. And in fact, it's really the only planet in the solar system you could do anything with. I mean, Venus has got a very toxic atmosphere, and it's too hot. Mercury's too hot. The outer planets like Jupiter and Saturn, they're all balls of gas. So if we want to move out into the solar system and take advantage of what Mars might have to offer us, then it would appear that that's the best place in the solar system for us to start extending our reach out into the universe.
What might have been the reason for the disappearance of that ship?
We suspect that there was a rupture in the propulsion system. It was just about the time when we were to fire the braking rockets on the spacecraft that would have slowed it down and put it into orbit around the planet. And we were doing some final maneuvers with the spacecraft to prepare it for that orbit insertion. And we think that the propulsion system probably had a leak, and that caused two things to happen. Either it caused an ignition and the spacecraft exploded, or the more likely thing we believe is that it caused it to go into an uncontrollable spin. And when it did that, then we were not able to have contact with it anymore, or get any more data, or to control it. And of course we can't be sure, we never know, but I think there's the most likely guess is that that's what probably happened, and so the spacecraft missed the planet, sailed on by, and has gone into an orbit around the sun and will be there forever.
Right. Now, the 4th of July, you have a landing coming up, which is Independence Day. Now, did you plan this because of the film, or did you, because I know, as I recall, when you're doing space shots and you were doing moon shots, the dates had to be right, and the orbit had to be right, and just everything had to be right to get into the orbit. Is the 4th of July, how long have you been, you just didn't, since the movie, come up with the 4th of July, or maybe that's what you did. I kind of think it's kind of involved to just get the right window. And of course, if you have your bad weather situation, how does this affect how does this plug in the weather and all that? Why the 4th of July, just symbolically, or the film?
Well, you'll recall that we landed Viking on the 4th of July in 1976 for the 200th anniversary of the country. July 4th is not a coincidence in this case either. We planned it that way, but we had an opportunity to do that because in the planetary cycles, when Mars was available to us to get there, because of the orbital mechanics that you refer to, next year, or this year, 1997, is the year, and also the spacecraft would be arriving in approximately that time frame anyway. So by playing around a little bit, we were able to schedule the cruise phase so that it would in fact land on the 4th of July. And we launched the Mars Global Surveyor spacecraft first, followed by Mars Pathfinder, which is going to land. But because of this trajectory, the Mars Pathfinder actually gets to Mars before Mars Global Surveyor, which we launched 3 months earlier. And in fact, those two spacecraft have just passed each other in space. It's the tortoise and the hare. And the Pathfinder is the one that's flying along on a more direct course. And by adjusting the orbital trajectory sum, you can come up with an ideal landing time, which we have, and July 4th is what we're going to target for.
What sort of a trip are we talking about? What's the distance and like that? Go ahead.
Well, once you've launched, there's not very much there to do. You're in a cruise phase that lasts somewhere on the order of 9 months to a year, and when you launch the spacecraft, you're fairly busy in the first month or so checking out the spacecraft to be sure that it's okay. after you've done that, then you kind of go into a quiescent phase, and it's just kind of cruising along there on its own, and you wake it up every now and then just to ask it how its health is and how it's doing. And that's really all you do till you get within about a month of being at the planet, when then you begin to do some checkout of the systems and get it ready to do its orbital insertion and landing. It's well over 1 billion miles to Mars, and so it takes a good bit longer than just your quick 2-day hop to the moon. And you can get there fairly quickly depending on the trajectory you go in terms of, say, 6 months, or if you take a more roundabout way to get there, you can take as long as a year. But that's what gives us a little more flexibility in launching more spacecraft more frequently, is to be able to play with the cruise phase and how long it takes to get there. So that's why some will take longer than others.
Okay, now, so the probe goes out, the one that's going to be digging in the soil. And the soil comes back, and there's the beginning of life here. This is the way it began on Earth, and possibly Mars has that potential. Where do you go from there? Is it a shock for you? And you go, what is your plan beyond finding something that is the beginning of potential life on Mars? Where do you go from there?
The missions are all intended to some extent to build on what we've gotten from previous flights. Now, the meteorite that we found that we believe is from Mars and may have had indications of Martian life, it just happened that we already had the 2 Mars probes that are on the way to Mars now. We had already planned to launch those, so it's just coincidence. We didn't very quickly put together a couple of missions because we found this meteorite. It's really a more of a methodical approach to, first of all, map the surface of Mars, and then by doing that, locate the areas where we believe they are going to have the most geological interest in terms of finding life on Mars. Then when we've identified those sites, then you set these series of landers to go and look at each one and see what you come up with. And obviously you're going to have more than one to do that. First of all, you want to have one just to go up and do a general survey of the terrain and what the immediate turf is like. But you also want to have something to drill down in there and bring something up. And you want to do it at several locations. It's just like if someone at another planet were to send a probe to Earth to find out whether or not there's life, you'd get very conflicting indications if you landed in the Great American Desert or, if you landed in the state of Vermont. Mm-hmm. So that's what we're trying to do, and we'd like to get some information from all of these areas, but our orbiting probe will give us the best clues as to where we want to go look, and then we'll take different probes and go to different areas, and the objectives will be slightly different based on what we know is there, because we know some areas are more likely to have had water than others, or oceans, or whatever.
Can you grow life on Mars? Do you know anything about the turf? You don't know anything about the soil. Can you actually begin life on Mars? Do you know enough about the planet to know whether you can do it or not?
Those are really questions you'd have to ask JPL. I'm not a Martian terrestrial expert.
Just a thought. I was in the Antarctic back in November 1994, and I can't imagine how these people did they just pick up a rock and that's the way it was? Did they go looking for something? I saw a lot of rocks in the Antarctic. Nothing that would occur to me to, they all of a sudden this rock, where did this, explain that. How did they say that rock was?
You have to ask Jet Propulsion Lab.
They go back to GPL.
Yeah, that's their world.
Yeah. I know, I don't know how you would have identified that as a Martian rock. Okay, in summary,
the main thing that we do here is it is our job to take the spacecraft themselves and get them ready to launch. That's our primary focus, and a lot of people don't realize that we have a lot of different NASA centers around the country that have different objectives. And for example, the Jet Propulsion Laboratory in Pasadena, California, they handle all of our planetary probes, such as the Martian probes or Cassini that's coming up to go to Jupiter and Saturn. And we have the Goddard Space Flight Center in Greenbelt, Maryland. Their world is astrophysics, stars and galaxies. They're responsible for the Hubble Space Telescope and all of those kinds of missions. Mm-hmm. But in fact, all of those probes have to be built and launched. And when it comes time to get close to launch, they come to the Cape for final assembly and checkout and to be placed on the rocket and launched. So eventually, the Cape gets involved in everything because this is the port to get into space. But that's kind of where our role ends when it comes to tracking the spacecraft and getting the science data back and deciding what those science objectives are going to be. Then that falls to those individual research centers that put together the project to start with.